168 plus 48 root 3 is your exact surface area. And that is in square inches because we are working with area here. Okay, cylinders. I have mentioned to my classes many times that circular figures are always going to be your easier ones. So having just done the hexagonal prism, hopefully you will see how much easier the circular figures are, because a cylinder is a circular figure. So Carter wonders, well, what if the bases are circular? Copy the cylinder below into your paper, which you don't need to do because this is your paper, and discuss with your team how to find its surface area and volume if the radius of the base is 5 units and the height of the cylinder is 8 units. Okay, so surface area and volume. Volume, of course, will be our easier way to go because all we need is the area of the base and the height. And we can find both of those pretty easily here given the data that we have. Well, the base is a circle. So to find the area of a circle, remember that is pi times radius squared. Our radius is 5, and our height here is 8. So we just need to simplify this, leaving this in terms of pi so that it is exact. So 5 squared is 25. Here we have 25 pi times 8. Anytime I'm dealing with 25s, I think of money. So 8 quarters. 4 quarters is $1, so 8 quarters is $2. So 200 pi will be our volume. And did it give us? It did not give us units here. It just said units. So cubic units because this is our volume. So for our surface area, we need to think of what an example of a cylinder in real life. So like a can, a soup can. So if this was a soup can, then the soup can label is the wraparound, the lateral area. The soup can label is the lateral area. So that's the wraparound, okay? Wraps around the cylinder, wraps around the cylinder. So if you can envision peeling a label off of a soup can and laying it out flat, it's a rectangle. The height of it is the height of the can, and the base of it is, when you unwrap it, it's the circumference of this circle. So the circumference of the circle, 2 pi times your radius of 5. So 2 pi times the radius of 5, which is 10 pi. 10 pi times 8 gives you an area of your soup can label here of 80 pi. So for your surface area, you need the top and the bottom, top and bottom. Okay, then you're going to add to that the lateral area, which is the label. Okay, so we have already found our lateral area, which is 80 pi. We just need the top and the bottom, which I do believe we already have. The area of the base was 25 pi. So the area of the top is 25 pi and the area of the bottom is 25 pi. Since we're leaving this in terms of pi, we're just adding the constants together. 25 plus 25 is 50, plus 80 is 130 pi. This is surface area, so we're working in square units. Again, if I went too fast, if I lost you, if you're confused, please, please, please rewind it, watch it again, post questions, ask questions. That's what we're here for. Okay, 2 challenges here. The first one is about Cavalari's principle. Bonaventura Cavalieri was a mathematician who helped to develop calculus, but is best remembered today for a prism named for him. Cavalari's principle can be thought of a way of finding volumes in a relatively easy way. It says, suppose you have a stack of 25 pennies piled on top of one another, and you decide to slant the stack of pennies by sliding some over. Does the volume change even though they are no longer stacked on one another? Well, I don't have a stack of pennies here. But you can think of the same thing as a stack of books that you slide to the side or twist, or a stack of paper. I do have a stack of cards here, okay? So here I have a stack of cards. So think of the volume of this stack of cards. The volume is the area of the base times the height, or times the number of cards on here. If I twist it or slide it in any way, did the volume change? Well, no, because I still have the same number of cards here. Okay, so just because you twist it or shift it or slant it, you're still going to have the same volume. Okay, so does the volume change just because they're no longer stacked one on top of each other? Well, no, it does not. And it does not for the paper or for the books or anything that you're going to twist. So the idea of viewing solids as slices that can be moved around without affecting the volume is called Cavalari's principle. Use this principle to find the volume of the cylinder below. Note that when the lateral faces of a prism or cylinder are not perpendicular to its base, the solid is referred to as an oblique cylinder or prism. So those of you who have already done your vocabulary, you were asking which version of oblique are we looking for? We're looking for the oblique prism. So how is the volume of this prism related to the one in problem 9-30? Well, notice here that you still have a base with a radius of 5 and you still have a height of 8. So if we are finding the volume of this, then we're going to be looking at the exact same thing as this one. Based on Cavalari's principle, just because you slanted, the volume has not changed at all. There's still the exact same amount there. So this is going to be the same volume as in problem 9-30. Okay, so for 932, Hernando needs to replace the hot water tank at his house. He estimates that his family needs a tank that can hold at least 75 gallons of water. His local water tank supplier has a cylindrical model that has a diameter of 2 feet and a height of 3 feet. If 1 gallon of water is approximately 0.1337 cubic feet, determine if the supplier's tank will provide enough water. I feel like I'm going to need a calculator here. So I will go ahead and bring one up for just that situation. Where's my calculator? There it is. Great. Okay, so that's over here to the side. All right, so I am going to go ahead and sketch out the tank that the supplier has. We have a tank, or the supplier has a tank. You can go ahead and sketch yourself out a cylinder here. Okay, and the tank has a diameter of 2 feet, which means it has a radius of what? Yeah, 1 foot. That's half of your diameter, and it has a height of 3 feet. Okay, if 1 gallon of water is approximately 0.1337 cubic feet, then we can determine how many gallons is in this. Okay, so this is in cubic feet. So the volume of this tank will be the area of the circle, area of the base, multiplied times the height. So pi times 1 squared times the height of 3, or pi, because 1 squared is 1, times 3, or 3 pi. Okay? So since we're going to be working in decimals here, we are going to go ahead and change this to a decimal. So pi is approximately 3.14. We're going to multiply that times 3. And that gives us a volume of approximately 9.42 cubic feet. Okay, if 1 gallon of water is approximately 0.1337 cubic feet, then how many gallons is in 9.4 cubic feet? We need one that holds at least 75. So let's set up a proportion. If 1 gallon of water is 0.1337 cubic feet, then how many gallons is in 9.4 cubic feet? So if we cross multiply here, we have, I'll get an equals there, 0.1337 times x equals 9.4. So to find out how many gallons, we are simply going to divide both sides by 0.1337. 0.1337, and that will tell us how many gallons we're dealing with here. So we have our 9.42. Add my 2 in there. 9.42, and then we can simply say divided by 0.1337, and that gives us approximately 70.46 gallons. So we needed a tank that holds at least 75 gallons. So will this tank work? Well, 70.46 is not at least 75, so nope. All right. Feel free to ask any questions on the discussion board or mark some for discussion at tutoring on Friday. Again, this was lesson 913. Thank you so much.